Good morning, my dear students. So today I'm going to tell you about the derivation of logarithm decrement equation. Okay. So what do you mean by logarithm decrement? So this comes under our second part of the dynamics of machinery subject. Okay. So module 1 normally 1, 2, 3 that is related to dynamics of machinery, and module 4 and 5 related with what. This vibration part. Okay, so earlier I told you about the what you mean by vibration, what are the different types of vibrations. Okay, so the definition related to vibration and what are the terms we are going to use in a vibration. So this is derivation, most important derivations, so many times asked in the VTU examination. Okay, so what do you mean by logarithm decrement? And they may ask you a question like this. Okay, define logarithm decrement and show that it can be expressed as delta is equal to 1 by n ln of x naught by xn, where okay, so this is about the logarithm decrement equation, but sometimes they may ask you in terms of n is equal to number of cycle, x naught is equal to initial amplitude, and xn is equal to amplitude after n cycle. Okay, so this may question ask you around 10 to 12 mark question, direct, very important. So let me understand the definition of this logarithm decrement. Okay, so logarithm decrement is denoted by delta, so and it is defined as the natural logarithmic of the ratio of any two successive amplitude on the same side of the mean position from its mean position in an underdamped system is called as a logarithm decrement. Okay, so take the any two successive amplitude from the same side from its mean equilibrium position, that is called as logarithm decrement. Okay, and it is denoted by delta. So and the formula is given by delta is equal to ln of x1 by x2. This definition suit for the logarithm decrement. Okay, so while solving the problems, logarithm decrement formula may changes to as per the given data. Okay, so I hope you understand the definition of this. So let me understand better than from the diagram. So here, so logarithm decrement is nothing but what? It is a ratio of successive two amplitude on the same side. Same side means x1 and x2. Here look at the observe the diagram. Okay, from its mean equilibrium position is called as logarithm decrement. Okay, so this is the I drawn the diagram here. So along the displacement source of time, so when it is started from the initial position, some distance, that is a reaches to till the time, that is, so here the sometime it will go positive side and sometime it will go the negative side. Okay, so this is about the logarithm decrement diagram. So the displacement of an underdamped system is given by this is we already derived this equation. Underdamped equation is equal to x of a into e to the power of minus zeta omega n into t sine of omega d t plus 5. Okay, give question number 1. So in the diagram, so x1 and x2 are the maximum amplitude of the particular cycle. Okay, with respect to time t1, t2, t3. Okay, so here it will, in this here the amplitude is go on decreases with exponentially. Okay, so the equation of the motion for this underdamped system equation is x is equal to x of e to the power of minus zeta n omega n into t sine of omega t plus 5. So this is about the, and the time period difference between t2 minus t1 is called as the time period, that is denoted by td, which is formula is given by 2 pi by omega t, where omega d is equal to undamped natural frequency. Okay, to solve this derivation of logarithm decrement, so let me understand displacement of an underdamped system is given by x is equal to a into e to the power of minus zeta omega n into t sine of omega t into t plus 5. So give question number 1. Okay, so when sine of omega d t plus 5 is equal to 1, the amplitude is maximum. Okay, and it goes on decreases exponentially with respect to time I shown here. So it will goes on decreases. Okay, so therefore sine of omega d into t plus 5 is equal to 1. So now from the equation number 1, so maximum amplitude is equal to what? So after putting that, a is equal to e minus zeta omega n into t. So let us assume the x1 is the maximum amplitude at time t1 in the diagram. So x2 is the maximum amplitude at time t2. So therefore the x1 is equal to what? A into e to the power of minus zeta omega n into t1, and x2 is equal to a minus e to the power of minus zeta omega n into t. These are the two maximum amplitude of the particular equations. So as per the definition, we know take the ratio of both the two. So as per the logarithm decrement definitions, ratio of x1 by x2 is equal to, just to substitute all the values, so here a get cancelled. So here x1 by x2 is equal to a minus zeta omega n t1. So downward direction, the downward value take top, that is minus of minus into minus zeta omega n into t2. So again you simplify, is equal to e to the power of minus zeta omega n t1 minus into minus of plus zeta omega n into t. Okay, so again x1 by x2 is equal to what? E to the power of minus zeta omega n, you take the difference between that, t2 minus t1. Okay, but we know that t2 minus t1 is equal to what is the time period, that is called as time period denoted by tp. Okay, we know that Tp is equal to time period is equal to T2 minus T1, and Tp is equal to difference between that time period is equal to 2 pi by omega d. Substitute this value, and but omega d is also we know that square root of 1 minus zeta square into omega n. Now substitute this value in the equation number 4, you are going to get what? Tp is equal to 2 pi by square root of 1 minus zeta square into omega n. Okay, so put this equation number 2, so you are going to get what? X1 divided by x2 is equal to e to the power of zeta omega n into 2 pi by square root of 1 minus zeta square into omega n. So omega n get cancelled, so remaining is x1 by x2 is equal to 2 e to the power of minus e to the power of 2 pi zeta divided by square root of 1 minus zeta square. Okay, give equation number 4. So this is an equation for computing the first two maximum amplitude, that is x1 and x2. But similarly we are going to get what up to till x2 by x3, x3 by x4, x5 by x6, like that you are going to get the same equation, so on. Okay, so x2, this is for the x1 or x2, and similarly x2 by x3 is equal to same, we are going to get e is equal to e to the power of 2 pi zeta divided by 1 minus square root of zeta square, and so on. Okay, so hence for in general we are going to write x1 by x2 is equal to x2 by x3 is equal to x3 by x4 is equal to up to x to the power of n of x of n plus 1 is equal to e to the power of 2 pi zeta square root divided by square root of 1 minus zeta square. Okay, so now take the log on the both the sides. So here ln of x1 by x2 is equal to 2 pi zeta square root of 1 minus zeta square. Here e to the power of get cancel, log get cancel. Okay, so remaining things you write here. So ln of x1 by x2 is nothing but what? That is the definition of logarithm decrement. So here I shown in the beginning only. Ln by x1 by x2 is equal to what? Delta. So in place of where ln x1 by x2 will be there, just to substitute delta. So remaining is 2 pi by zeta is equal to square root of 1 minus zeta square. So give question number 5. Okay, so but zeta is equal to very small, so therefore square root of 1 minus zeta square is equal to 1. So substitute in this equation delta is equal to 2 pi by zeta. So equation 5 is also called as logarithm decrement equation. Sometimes they may derive you up to equation 5, but in the given question they are asking what in terms of number of cycle and the initial amplitude. Okay, so to derive that again we go further one more step. Okay, when we can express the logarithm decrement in terms of amplitude, let us assume x0 is equal to amplitude of certain maximum time and xn of amplitude of after n cycle. Okay, therefore the amplitude of ratio of any two successive and consecutive amplitude is given by x0 by x1 divided by x1 by x2, x2 by x3 up to dash up to xn minus 1 divided by xn is equal to e to the power of delta. Okay, again same, x0 by xn is equal to x0 by x1, x1 into x2, x3 by x4 up to xn minus 1 divided by xn is equal to e to the power of delta into n times. Okay, that is equal to e is equal to delta n. So here again take the log on the both the side, ln of x0 by xn is equal to n into delta. Therefore delta is equal to what? 1 by n is equal to ln of x0 by n. So this is an expression for in logarithm decrement in terms of the number of cycle and initial amplitude. Okay, so where n is the number of cycle, x0 is the initial amplitude, xn is equal to amplitude after n cycle. Sometimes they may ask you up to till now, or sometimes they may ask you up to till delta is equal to 2 pi zeta square root divided by square root of 1 minus zeta square. All are equations of logarithm decrement only. As per the given decrement of the given data in the problem, we are going to use the formula. Okay, so this is about an expression for logarithm decrement in terms of number of cycle and normal definition. Okay, I hope you understand this derivation, and this derivation is very important for the point of examination. Okay, so just to understand that logarithmic decrement is denoted by delta, and it is a ratio of two successive amplitude on the same side from its mean equilibrium position. Okay, so this is about the definition of logarithm decrement. So it is defined as the natural logarithm of the ratio of any two successive amplitude. So here the successive amplitude is x1 and x2 on the same side from its mean equilibrium position. Okay, from its mean equilibrium position. Okay, so that is called as logarithm decrement, and is given by the formula delta is equal to ln of x1 by x2, and one more delta is equal to 2 pi zeta is equal to square root of 1 minus zeta square, and 1 by n ln of x0 by xn. These are the three formula we are going to use the logarithm decrement while solving the problem. Okay, I hope you understand this. Okay, and one more is you have to remember this formula, that displacement of underdamped system is given by, so this is very important, x is equal to a e to the power of minus zeta omega n into t. Okay, sin of omega t t plus phi is equal to 1. So this is a general equation we are going to use, solve for the underdamped system equation, and while solving the problem also understand underdamped system vibration, you are going to use this formula. You have to remember this, no way to derive this equation. Okay, so I hope you understand this logarithm decrement derivations better. Okay, now I'm going to I hope you understand this. Now I'm going to stop this. Thank you very much for listening. Okay, thank you.